Welcome, everybody, to From Nothing to Mario in 2 hours. I am Willem Dalbenthal, the headmaster of the Indie Game Academy, and I shall be the instructor today. I'm getting set up here, having a little sip. Got to have your coffee to program. Everybody knows that. We have 5 people in the waiting room. There were quite a few signups for this, so hopefully this is going to be a good one. I'm going to let people in just one moment. Let me check some settings, make sure everything looks good. All right, should be fine. Okay, I'm going to let people in. Welcome, everybody, to From Nothing to Mario in 2 hours with the Indie Game Academy. I am Willem Dalbenthal, the headmaster of IGA, and I will be your professor for today. We're going to wait a couple of seconds because, I mean, y'all know how online events go. Everybody's going to be late. We have actually over 30 signups for tonight, so it should be a pretty packed room. A couple of ground rules for you here today. You are more than welcome, actually encouraged, turn on your video cameras. Helps me to teach better. I can tell if you are thoroughly confused and need help understanding something or something else. It's also just like a little bit more human that way. So feel free to turn on your camera. Hi, Miguel. Welcome. However, with your mic, please keep yourselves muted unless you have something to say. You can totally jump in and ask a question. Hey, my thing is broken. It's not working. What's up? Who's that? Fernando. Welcome. You can totally jump in and ask a question should you need it. But please keep yourself muted unless you are currently saying something, because we don't like to hear dogs in the background and all kinds of stuff like that. So like I said, this is From Nothing to Mario in 2 hours. Does everybody have Unity downloaded and installed? It's a very important step. For this Unity class, you do indeed need Unity. Hello, Kenny. Welcome. Great, Justin. Great, Fernando. Awesome. Juan, the version mostly isn't going to matter. Matters a little bit. So if you want to match exactly what I have, I just have the most recent stable version, which is currently at 2021.3.2 F1, which is just what Unity will tell you to download if you go to the download page. But I can mark that in the chat if you want. There may be minor differences if you don't have the exact same version of me as me, but for the most part, it doesn't matter unless you're like super, super far behind. What's up, Safak? Welcome. Are you guys able to unmute yourselves? Okay.
Yes.
Perfect. All right, I think we're all set up then.
So.
Perfect. Welcome, welcome. This is very exciting. Okay. So yes, get yourselves Unity downloaded if you don't already have it. If you are unfamiliar with Unity and getting it all set up, you will actually be downloading, or what I recommend you do, download Unity Hub, which is just a tool to manage different versions of Unity and your different projects. And then inside of Unity Hub, download the most recent stable version, which right now should be 2021.3.2 F1. The other thing I will pass your way is our resources folder. Let me get the link for that, just a second. And we'll get started actually pretty much right now. And if people join late, that is on them. I'll get this link for you and we will jump right in. All right. So this is the resources folder. There are scripts and images and a couple of other things in there, including a handout to give you some additional homework after we finish today's class. So you have something else to do, something to apply these lessons to. This is a, let's do our official introduction, then let's actually start. So I'm going to repeat myself here a little bit, but that's because people are jumping in and out. Like I said, my name is Willem Dalbenthal. I'm the headmaster of the Indie Game Academy. We are a gamified online school. We do all kinds of ridiculous fun stuff, game jams, classes like this. Our main bread and butter is what we call IGA Level 3, which is a 3-month-long video game boot camp. It's basically online Hogwarts. You get sorted into a mock indie studio. You in your studio, one of our 4 noble houses you can see floating behind me. You and your studio work together to come up with an original game concept and then publish that concept and monetize that concept to a store of your choice in 3 months under the guidance of 7 industry professionals. So in the next cohort, we've actually got one of the art directors from Minecraft. We've got one of the game designers from Wizards of the Coast, the guys who make Magic the Gathering, and a couple of other cool professors. So, we like to do stuff like this as outreach and as a way to promote our classes. So towards the end, I'll tell you about those classes, and I will give you a link to talk to me if you're interested in that. But otherwise, we're just going to have a fun time talking about Mario. I have 3 simple rules for my online classes. Number 1, turn on your cameras if you're comfortable doing so. Like I said, I love to see your faces. It makes teaching you a heck of a lot, both easier. It's just like much better for me to see that somebody is confused. And then it's also just more human for me. There have been classes where I'm staring at a bunch of blank screens and it's a little depressing. 2, keep yourselves muted unless you are currently asking a question. You are totally welcome to jump in and ask questions as we go. I actually encourage you. What's up, Justin? You must be a streamer. Are you a streamer, Justin? Nice. You got an awesome setup, by the way. Weird. So yes, I encourage you to jump in and ask questions. It's way more valuable to me. It's a lot better for me as a teacher if I know that something is wrong early. If I find out that you had a problem 30 minutes ago and you're still trying to catch up, it's almost impossible for me to catch you up in that time period while I'm also trying to manage the other classes. So better for you to just be like, sorry, this is not working. Can you help me with this? Part of the understanding of group classes is that that's going to happen. And most of the time it's actually valuable. Even if your code is working, you may not understand why it's working. And so being, solving somebody else's problem is actually going to help out. So just let your problems be known. Let's talk about it if you run into something. All right. And then the third most important rule, let's have some fun and let's be kind and good to each other. We have the power to create the spaces that we exist inside of, right? So let's not be dicks. Let's be understanding. If somebody keeps asking questions, same person keeps asking questions. Every 30 seconds, freaking Fernando keeps asking questions over and over again. This guy, let's celebrate that. Let's be happy for Fernando for learning so much, right? Let's be good. Let's create a kind, happy, positive space. So let's begin. If anybody wasn't here, this is indeed From Nothing to Mario in 2 hours. If you did not come here to learn how to use Unity and make a very simple version of Mario, then you're in the wrong place. Leave now. You are indeed going to need to download Unity. Here is Unity's download page. On the Unity download page, you are going to download what's called Unity Hub. This button here. This is a semi-recent tool. That's not quite what I wanted. Where's Unity Hub? I don't think I have it open. 1 second. This is a semi-recent tool. It's a good, I think like 6 years old now, so not that recent, that they added when they realized they had so many different versions of Unity. You're also very much welcome to drop, doesn't work with Unity, I just realized I'm re-downloading 2019. Safak asks if the 2022 version of VS Code works with Unity. I actually don't know. I use the 2019 version, but only because I've been lazy and haven't updated. So if it's not working, try the 2019 version. So Unity Hub, it's a single place for us to go to manage all of our different projects. This is a new computer, so I don't have too many going on here, but if you are a ongoing Unity developer, you will quickly wind up with dozens of projects. So it's awesome to have them all in one location. And it's a place to manage the different versions of Unity that you have on your machine. Different games will actually use different versions. In an actual production studio, the most common practice is to do a full release of your game. Then when you release it, update Unity, and you don't release it during the production cycle because it could just introduce strange complications here and there. For the most part, they're interchangeable. But occasionally a feature that was core to your game stops working or something like that, and then it's a huge pain. So mostly you're going to use the same version for your game until you're ready to release or update, and then you'll update Unity all at once, make sure it all happens. So in our Unity Hub, yes, let me make sure. I'm going to say one last time, just because this happens so often. I don't want to sound like a broken record. If you have not already downloaded Unity, if you have not already downloaded Unity Hub, please do that right now. there's a link in the chat. Once you download Unity Hub, this is the step that some people might miss. You're going to need to make a developer account, which I believe you can just do on their website. And you will need to manage your license here. If I look under my name, you can see there's manage licenses. And you will be totally fine with a personal license for a long time. You can see I'm still using a personal license. I am no longer building professional Unity games for somebody else, but this works totally fine. Their general rule is that as long as your game is making less than $100,000, you can use a personal license. So most of you will be using a personal license for a long time, and it's free. It's one of the reasons we all use Unity. So just make sure you have this set up, and then you should be good to create new projects. So in the top right, you're going to hit New Project, and you'll see that Unity presents you with many different options. This is actually a great place for you to start exploring. Many different people learn different ways, but what I personally believe and what we do at the Indie Game Academy is very much self-directed learning. Just experiment, mess things up, get dirty, because it's better to mess things up earlier in your career. Actually, does anybody know who Jesse Schell is? The Art of Game Design. If you're not comfortable talking, you can also use the chat. And you can also unmute if I'm asking questions. Jesse Schell. So the Art of Game Design is one of the, it's probably the game development textbook, if there really was one. And he has this wonderful quote: your first 10 games are going to suck, so you might as well get them out of the way as fast as you can. That's very much what we believe in here. And that is very much how I believe you should be learning. Oh, that's awesome, Justin. Nice. You met him. That's great. He's a great guy. So the reason that I say that is a lot of these templates that they have, and they also have some samples as well, which it seems like I don't have any downloaded, but you can get other games. You can check out their learning section, for instance. Here's a 2D platformer. You could maybe check this out and make a different version of Mario or a karting game. A lot of these different resources that they have available to you are like great places to start. But let's start with a fresh, empty project. For the most part, when you make a game in Unity, you're either going to click 2D or 3D. We're making a game of Mario. Are we in 2D or 3D? 2 dimensions or 3 dimensions? 2. Fantastic. Excellent. So click on 2D. We're going to talk a little bit later, but this actually makes basically no difference, which is kind of hilarious. So our project name, you can call it whatever you want. I'm going to be providing you assets. That folder that I sent has a couple of Mario pictures in it and stuff like that, but you're welcome to use your own pictures. So maybe right now come up with, what the theme of your platformer is going to be. Maybe you're going to do vampires or Metroid or something. I don't know. Name it something cool. I'm just going to name it Simple Platformer. I also usually recommend that you have a single folder where all of your projects live, not for any particular reason other than it is a little bit more organized that way. Then you're going to hit Create Project. This is going to take a while. Don't worry, once you've done it once, Unity will be faster moving forward. We will talk about some of the limitations of Unity here, even while we are learning how to use it. And one of the limitations is it has become quite bloated. It is a very big engine at this point with a ridiculous number of features that sometimes cause weird bugs, weird error messages, and definitely take a lot of time and space on your computer. So that can be a bit frustrating. And if you are looking for something that's like quick and zippy, there are other options out there that do a good job. But we will wait patiently for Unity to do our initial setup. And actually, while this does that, this is the project that we'll be making. Very, very simple. Just a couple of core features that our game is going to include. Once it starts running here. Here we go. So we've got a, looks like I'm zoomed in, there we go. We have Mario, who can turn left and right, but otherwise does not animate. He jumps up and down. He jumps up on blocks. He can collect coins. He can hop gaps. He can get killed if he touches that flower, but I won't do it for right now. And he can hit this flagpole. And that's it. I'm trying to give you just enough tools. The way that we do these classes is that I'm going to show you kind of just the barest of breadcrumbs so that hopefully you can continue your lessons moving forward and keep getting curious. But a lot of these scripts you're actually not even going to write. You're going to write 3 of them today so that hopefully you know enough to continue to write your own scripts. But otherwise, We're not going to get too complicated since we've only got 2 hours to put together a whole game. Yes, Miguel?
Yeah, I have a question.
Yeah.
So this project we're going to be doing today, is that going to be able to be used as a, say, a template or a bed for other projects down the line? Say, like, can I change up the sprites and stuff eventually?
Yeah, that's a great question. Absolutely. We don't hold any like ownership of this script or anything like that. We wrote this script. This is all stuff that we created for you, but we don't ask any license from you or anything like that. So you are more than welcome to copy and paste, to use chunks of this in your own games, to change all the sprites, change it into anything you want. That's one of the things we believe in. We want you making and publishing your own games. So yes, it's the short answer. All right. So once you open up Unity, you're going to be presented with a screen just like this. This is what's called an IDE. Anybody know what that means? I see a nod from Safak. What does that mean? Oh.
Sorry, that was not for you. I just ran out of space in my computer. I'm trying to fix it.
Oh, no. All right. Let me know if you need any help with that. So an IDE is called an integrated development environment. And it's actually one of the things that made Unity so popular when it first came out. They did not invent it. There are plenty of other examples before it, but some would say anyway, they perfected it. An IDE, or an integrated development environment, you can think of it kind of like a Photoshop for making games. It's one location we come to do the vast majority of the stuff that we do to make a game. And we actually physically manipulate a lot of the game rather than, for the most part in the old days, we would have just been writing code, or we would have made our own editors. So we would have programmed like a map editor or something like that, that then we would use to design the maps. These days we have Unity, which has a ton of tools built in, like I said. So this is the Unity IDE. It is split into a bunch of different tabs. So we see hierarchy, scene, game, inspector. By the way, these classes are expecting from nothing to Mario, or expecting that you have no experience. If you have some experience, if you have some engineering experience, try to just, breeze through it, learn what you can from this class, maybe add some cool stuff to your game while you're waiting for me to explain stuff you already understand, and try to help other people understand too. So if you feel like there's more to what I'm explaining, leave it in the chat, help out the rest of the people in the room. So each of these tabs do something a little bit different. I'm going to ask you to actually set up your Unity IDE a little bit differently, just because I think it's more conducive to beginners. So right now we can see that the scene and the game tab are on the same window, and I can only see one at a time. These are both hypercritical portions to your game. So go ahead and click and drag the game tab, and you'll see that Unity allows you to restructure your IDE however you want. I tend to like it over here on the right-hand side, so that I have both my game and my scene in the center of my IDE. And then do the same thing for me down in the bottom left. You see both the project and the console are sharing the same window. But once again, they're both pretty critical windows that you'll be using a lot. So I'm going to click and drag the console and move that over to the right-hand side. So now I can see both. And also, for the most part, the console is more valuable to be nice and wide, and the project is not as important. So I'm going to drag over the side so that I have a nice big space for my console. And I'm going to also drag this down a little bit, the inspector over a little bit, just make some more room. By far the two most important windows, and I'll talk about what each of them does in just a second, is the scene and the game. So this is going to be where you're doing most of your work. All right. Now, the last thing I'll ask you to do before we really begin here is in the bottom left, the project tab. You see how there's 3 little dots in the top right of that window? That typically in Unity means this is the settings for that thing. In this case, it's the settings for the project. So if I click that, we'll see a bunch of options. Go ahead and change your project from a 2-column layout to a 1-column layout by just clicking on it. This is more similar to how like Finder or File Explorer shows files. And it just makes more sense to me, and I find makes more sense to students. You're welcome to change up any of this, especially if you're already familiar with Unity. But if this is your first time, definitely just mimic my screen because it's going to be easier for you to follow along that way. Okay, so we have all of our windows set up. Anybody having an issue so far? Always better to stop me sooner than later. Fantastic. Well done. Bunch of pros in this room. Okay. So like I said, Unity is an IDE. It allows us to build games in place. It allows us to actually manipulate our games visually rather than just programming stuff. Programming stuff is definitely still part of it. If you're thinking you're going to get away with making games without programming, I'm sorry to break it to you. That's not going to happen until you join a company and somebody else does the programming for you. Programming is still a huge part of what we're going to do today and what you will do as a solo developer. But Unity takes a lot of the heavy lifting out of the programming. I don't need to make a map editor anymore unless I want to, or it's valuable to that specific game. So let's talk about what each of these tabs does specifically very quickly so that you have some context here. We will start with the left-hand side, the hierarchy. So the hierarchy is everything that exists in our current scene. Unity is split up into what we call scenes, which you can think of for the most part like levels. So if I was making a Mario game, which turns out we are, I would have a scene for each level. I'd have a scene for World 1-1 and a scene for World 1-2 and a scene for World 1-3, probably. But we use them for other things too. We might have a scene for the main menu. You might have a scene for the payment page. We might have a scene for the, I don't know, login page, right? So a scene is just like one visual layout that we are saving. Currently, we just have a single scene named sample scene, and we have a single game object inside that scene, which is what?
Camera?
Yes, my good Miguel. Oh, Harvard grad over here. Yes, main camera. So the main camera is what we call a game object. I want you to click on the main camera, and you'll notice a couple of different things happen. So first of all, we highlight it in hierarchy. Second of all, we see a widget appear here in the scene. We see that the camera, this little rectangular white box, is selected. And then we see over in the inspector, a bunch of information dropped out. So this is how it works. The scene tab is where we actually visually lay out our level. So we're going to put some blocks here and a piranha plant and a Mario and a flag and stuff like that. And we'll be able to actually manipulate it. The hierarchy is simply a drop-down list of everything that's in the scene. It's really just for convenience. So we don't have to go and find, the 16th block that we put in our world. And then the inspector is everything that there is to know about the currently selected game object. A game object is a special term that the Unity developer has created for us, and all it means is something that is allowed to exist in the scene. So the main camera exists in the scene. It is a game object. You'll see in the inspector that there's all kinds of information about the camera. So for instance, it's got a position, it's got a rotation, it's got a culling mask, which you'll learn what that all means as you get more advanced. But the one thing I want you to manipulate right now, I'm going to turn you all into game developers right this second, is the background color right there. So on the main camera, with the main camera selected in the inspector, go down to the camera component, which we'll talk about what that means in a second too, to the background, and click this box here. And Unity will actually make a new dialog box open up for us with a color wheel of options. And this is actually going to edit the background color of our game. So depending on what game you're going for, if you're making something about vampires or something about Mario, choose a good solid background color, maybe a sky blue, or maybe you're going for something more trippy, whatever floats your boat. I'm gonna go for a nice lilac, why not? All right. Okay, so the inspector is everything about the currently selected game object, and then it's also where we do a lot of our editing. You can see that we just changed something in the inspector and it directly affected our game. And you can do that with all kinds of other stuff. You can change the scale, which won't matter for the camera, but we'll see some examples of that mattering in a second. You can change all kinds of information here, and we'll see lots of examples of that happening in just a moment. All right, now, the project in the bottom left will matter more in a bit, but this is basically our library. This is where all of the stuff that we have available to us to make our game with will live. So we're going to put our images in there. We're going to put our sounds in there. We're going to put our scripts in there, etc. The console is kind of like our warning lights. If any of you are already coders, you know what a console is. If you're not a coder, this is where the engine communicates with the game developer. So the engine will say, hey, I've got a problem, and it will list here. But your users, the people who are playing your games, will never see the console. So this is just for you. And then the last tab that I haven't mentioned is the game tab. Can anybody guess what that actually does?
Place, I guess.
What's that?
Plays, I guess.
Yeah, that's where you play the game. Yeah, this is another revolutionary. Once again, they weren't the first to do this, but they were the first to really popularize it. Instead of having to either build the game to my phone or a computer or a console where I would play it, instead of having to even open a simulator or an emulator, a separate program that can pretend to be my phone, I just have my game right here and I can play it at any second. And for those people who have been around, who are just starting game development, that's not going to feel revolutionary. But I built games back before this was a thing, and this is goddamn amazing. So this is where we can actually play our games, and we can play it at any second, at any time. It makes our development so much faster. All right, what's next? Let's drop some stuff into our scene. So first thing we're going to do in our hierarchy, in the top left, let's hit this plus button. See that right underneath the hierarchy? And go down to 2D object, sprites, and let's go for a capsule, actually. We're going to make ourselves a Mario. Now I kind of cheated here, I'll wait. So hit the plus button, 2D object, sprites, capsule. Does anybody only see sprite here? If this only says sprite and it doesn't have multiple options, that means you have a pretty old version of Unity. You can probably still follow along. Just let me know if you're having issues. All right, so we have a capsule in our world now, and we can see that our capsule appeared in the hierarchy. It appeared in the scene, and if we click on it, we'll see that it has some stuff happening over in the inspector. We can also see it here on the game. So the game is a direct representation of what our players are going to see. And you'll see that the camera is what actually designates the bounds of our game. So if I move my capsule outside of where the camera can see, which is what this white box is, the sprite here goes missing. So this is what the player can actually see, this white box. And one of the things we'll wind up doing in this game is we'll make it so that we can move the camera. So that way we can see more of the world as the player moves around. All right, now let's run through the basic tools of Unity. So this little drop down here, this is something that got added in 2021. If you have an older version, your tools are going to be up here in the top left of your window, but they're the exact same tools. So the very first tool is the hand tool. This allows you to just drag around the world. As you make bigger and bigger levels, you're going to need to drag around more and more. You can zoom in and out with your mouse wheel. And a really actually important tip, this was a pain before I realized this was a thing. If you double click on anything in the hierarchy, your scene will immediately zoom to it. So if you ever get lost or if weird stuff is happening, you can just double click and go and find your player or your camera, and you'll be back in sort of the correct position. Now, a hot tip for you, you can move on to the next tool, the move tool now. A hot tip for you, any of the other tools, when you have them selected, if you right click in the scene, you'll still get the hand tool and be allowed to drag around. So for the most part, you don't really need the hand tool. I actually find that in 3D development, I use the hand tool a lot. In 2D development, I basically don't. All right, next tool is the move tool. This one is pretty self-explanatory. With a game object selected, so I'm going to click on my capsule. I can move it along one axis by clicking and dragging one arrow, or the other axis by clicking and dragging the other arrow, or both by clicking and dragging that square in the center. Now you'll notice, by the way, that values over here in my inspector are changing. So as I move it along the X and Y, the inspector is updating and keeping track of where this object is, and you can in fact edit these. So if I wanted to reset my character to a perfect 0, 0, I can do that in the inspector and it will be directly reflected in the scene. The next tool is the rotate tool. It does what you'd expect. You can click one of these axes to rotate the player, but then it gets a little weird once you start rotating along these axes. It kind of looks like I'm rotating in 3 dimensions, even though this is a 2-dimensional game. Does anybody know why it looks like that? Anyone have a guess? Plot twist. This is a 3D game. So this is actually an important fact. I'm not just showing this to you as a fun fact. Unity was built for 3D games first. That was actually their sort of marketing gimmick at the very beginning. We build 3D games because 3D games were very challenging back before IDEs. But once they started getting more popular, a lot of people started using them for two-dimensional games. So they added this two-dimensional layer on top. But for the most part, it's still just their 3D engine, except that we use a different kind of camera. So our camera right now, if I click on my capsule, and by the way, if you're confused about what I'm doing, in the very top of my scene, there's a little 2D toggle. I can switch between 2D view mode and 3D view mode. If I click on my capsule in 3D view mode and I drag it further back away from the camera, we'll see that in the, well, it's also centered all weird. Let me reset this for us. We can see that it doesn't affect the size of the capsule at all, right? And that's because this camera is an orthographic camera, which basically means it smushes everything into a single two-dimensional plane. If I switched this camera to a perspective-based camera, this is basically all 3D is. Now it actually represents the capsule as closer or further away for the player, depending on how close the camera is. So it's actually kind of a misnomer that we're building, and you should switch this back to orthographic if you did switch it to perspective. We do want to make a two-dimensional game. It's kind of a misnomer that we're even making a 3D game. Now, the reason that we're even making a 2D game, this is in fact 3 dimensions. And the reason that matters is for a couple of little reasons. One of them is rotation. Sure seems weird that we're rotating in 3D. It's because we literally are. And then a couple of other moments that I'll point out when we get there. Just remember, though, the important thing to remember, Unity is still 3D even when you're making 2D games. All right, next tool is our scale tool. This one's pretty straightforward. You can scale along one axis, the other, or both. Next is the Rect tool. This is probably the tool that I use by far the most, especially in two-dimensional games. So this is something like Photoshop or a Microsoft Word where you have the 4 corners that you can click and drag on an object. And then if you hold your mouse kind of away from the corners, you can also rotate along the Z-axis, which for the most part in 2D is going to be the only axis you need to rotate along. And then if you click and drag on the shape itself, you can move it. So that's why I like it. It kind of is a nice combination of tools. That is the Rect tool. And then the final tool is the actual combination of tools, only it's way more confusing and I never use it. So this is the, what do they call it? The transform tool. Oh, they changed it. It used to be called the, what was it? Move, rotate, or scale tool or something like that. But regardless, this is literally all of the tools combined in one. It's a bit much. I don't know many people who use it. If you want to use it, go for it. All right. So now we know what all of our basic tools do. We can see that our capsule is all messed up. If we want to fix our capsule or any other game object, if we go to the top right of the transform, when we select the castle, there's the 2 little drop-down dots. Click that and hit reset. That will reset just this component, which we're going to talk about very soon now. But in this case, it'll reset the transform back to all of its default values, fixing the capsule and making it not messed up. All right. So let's move on to some physics. Right now, in the top of our screen, there's still some buttons that I haven't mentioned, which are these top 3 buttons: play, pause, and step over. Now, these are how we actually get our simulator to run. So this is how we actually run our game. If we hit play, our game will run. If we hit pause while our game is running, it will pause. If we hit step over, that's for more advanced debugging. You guys don't really need to worry about that right now. What do we expect is going to happen when I hit play? What is this capsule going to do? I'm saying like, yeah, actually nothing is going to happen. Unity is doing a little setup here for me. And then we can see that nothing actually happens. We might have expected it to fall. We might have expected some gravity, but Unity will not apply gravity to anything that we don't tell it to apply gravity to. We don't tell it we actually want this thing to be a physics body. So let's make this thing a physics body. Unity uses what are called components. And we can see on our main camera and on our capsule, both of those objects have 2 components. Tell me what those 2 components are. "2D levels in a 2D game." It is possible to make 2D levels in a 2D game. For the most part, as you are developing, You won't even notice that it's actually 3D, but there are just going to be a couple moments where you have to remember that. That's why I pointed out. And I'll point out one of those moments in a second, actually. All right. What are some of the components? I haven't told you much about what components actually are. I'm just asking you to guess here. It's okay if you're wrong. On our main camera and our capsule, you can look over in the inspector. There are 2 components on both of them. What are those components?
Is it the material and the camera position?
Not quite. Tag and layer, not quite, Colleen. Good guess. It is actually these bars here. Each one of these represents one component. So it's the transform and the sprite renderer on the capsule. And then on the main camera, it's the transform and the camera. So this is another one of those things that Unity didn't do first, but they popularized. This is called component-based programming. In the old days, we used to do object-oriented programming. Well, we still do it. I shouldn't say old days, but before there was component-based programming, object-oriented programming was the most commonly used thing. And that basically means that when we write a script, we write the whole script for that thing. So if we're going to write a dog, we're going to write a dog script. We're going to write all the things that a dog does. These days, with component-based programming, we break up the dog into pieces. So instead of writing just the dog, we would write like a run script, and we would write a bark script. We would write a tail wag script, and then we would stick those components together to get a dog. Why is that good? Because it is good. Why would we want that?
Potentially because we can use components later. I can use the run for the dog and for a fox or whatever other animal that I want to.
Nailed it. Yes. I didn't see who that was, but well done. Was that Cindy?
No, it was me, Tamiris.
Ah, Tamiris, thank you. Yes, perfect. Nailed it. Exactly. If I want a cat, now I've already got the run and I've got the tail wagging. And all I need now is the meow script. And I stick that on and now I've got a cat. The other thing is, if my running doesn't work, then I just go straight into the run script and know where to fix it. So there's a couple of big advantages to component-based programming. Our capsule currently has 2 components: a transform, which is a component that just knows about physical location in space. And in fact, every game object will have a transform. And then it has a sprite renderer. It does one discrete thing, which is how we know we've done a component well, if it just kind of does one thing. It renders a sprite. In this case, the sprite it's rendering is this built-in sprite that Unity has available for us called a capsule. So we're going to add one more component to our capsule to give it physics, a component whose only job is to do physics. So on the capsule, with the capsule selected, go to Inspector, hit Add Component, and search for rigid body. Now here is one of those moments that it matters that we remember this was a 3D game first. We see a 3D engine first. We see rigid body and we see rigid body 2D. Which one should we add to our 2D game? Rigid body 2D, yes, congratulations, yeah. So you can see that they made rigid body first because they didn't bother to designate it rigid body 3D. And then later they added rigid body 2D. This is actually going to be something that you run into multiple times, where there will be something with no name and then something that says 2D. So just make sure you use the 2D version, because this will actually make really weird stuff happen that will be very confusing until you remember that that's a thing. So make sure you click rigid body 2D. And that is actually all you need to do. This is the magic of Unity. It takes away a lot of our programming. If I hit play now, on the top of the screen again, Unity will compile for a second, and then the game will begin to run. And our capsule will fall to its doom. And now you have physics in your game. Congratulations.
Excuse me.
Yeah.
My capsule just kind of disappeared. It's just not showing up.
It disappears?
It's not even here, even when the game is paused. I'm
Ah,
sure
there's a couple things that could be going on. The first thing I want you to try, it's not in the game at all.
No.
Okay, so this is what I bet happened. This is another important moment. This is why it matters that this is a 3D engine. So if I switch to my 3D view and I look at my capsule on my main camera, you can see that my main camera, if I select it, has a rectangle that indicates where it's actually allowed to see. If I move my player behind my camera, the camera is no longer able to see it. Is that what happened?
Yes, it is.
Nice. Been doing this for a while. All right. So we have a capsule that falls to its doom, which is great, but we want a little bit more than that. So let's now move Mario up, or what will eventually be Mario, and put him, somewhere up here. And let's add a second object to our scene. Let's add a platform for Mario to actually land on. I'm going to go up to my plus button again. I'm going to go to 2D object. I'm going to go to sprites. I'm going to go to square and drop a square somewhere under Mario so that he can land on it. Now, who wants to bet what's going to happen when I hit play? Is Mario going to land on the platform? Yay or nay? Thumbs up, thumbs down. Speak now, forever hold your peace. Oh, it really takes a second. No, Mario does not land on the platform. And this is the same thing that I was talking about before. Unity is not going to assume that we want physics. Good job, Carl. Good job, Miguel. Good job, Kenny. Good job, Stefak. So many good answers. Fantastic, everybody. Unity is not going to assume that we want collisions without telling it that we want collisions. And that is, once again, simply a component that we have to add. So on our capsule, let's click our capsule, go to inspector, hit add component, and search for collider. Just type collider, Collider. Now, another moment where it matters that this is a 3D engine. You can see all these colliders that don't have a name next to it. It doesn't say 3D. Those are all 3D colliders. Don't use those ones. It'll do weird things. All the ones that say 2D are available to you if you're making a 2D game. Now, for the most part, colliders are interchangeable. I could use any of these 2D colliders for Mario, and it would mostly work. But what you're looking for is the collider that's going to best fit the shape of this sprite. Now, even though we're going to change what Mario looks like in a bit, I'm going to tell you to use a Capsule Collider. And the reason that's the case, this is just really common, actually. The reason that that's the case, it's very hard to see, but if you zoom way in, you'll see a green line now all the way around our sprite. And if I change down here the size of my collider, which you don't need to do, this is just so that I demonstrate for you, we can see the outline even better. That is our actual collider. That's the thing that's going to run into stuff. So right now, my character kind of has a little force field. The reason that we often use capsule colliders for characters, unless they have to be very accurate, like a fighting game or something, is because this mimics a human body decently. Its head is kind of up here, its legs are a little bit harder to hit, and then the bulk of the torso is here in the middle. But it's also a very simple shape, so it's very light on our processor. This is not going to cost much for our machine. All right, so we have a collider on our capsule, but we're still not done. If I hit play, Mario would still fall through my platform because the platform also needs to know that it is supposed to collide with stuff. So I'm going to hit my square here. I'm going to hit add component. I'm going to search for collider, and this time a box collider 2D will do me just fine. New component. And then when I hit play, Mario will fall and land on the platform. Ta-da! Amazing. All right. Does everybody have a little pill that lands on a little box? Anybody having issues?
When I press play, my square just kind of disappears.
Is it the same thing?
No, it just disappears from the scene entirely.
Disappears from the scene entirely. You can't see it in the hierarchy?
No, not at all. So I have to add it again every time.
Ah, that's weird. Let's see. Are you comfortable sharing your screen?
Yes.
All right, let me give permission for that. 1 second. All right, go ahead and share your screen. We'll try to figure it out. And this means everybody is now on the clock. Can you fix his problem before I fix his problem? All right, so we've got a square, we've got a capsule.
Yeah, I just added the square.
Okay. If you hit play.
Yeah.
Unity takes ages to run because it's Unity. This is actually one of the big drawbacks. 2021 is also, interestingly, a lot slower than 2020. I still sometimes use 2020, but I don't want to be showing you guys outdated versions.
So is it running?
Yeah, it is currently running. So actually, this is a great tip for everybody. Why don't you stop? So hit the play button again to stop it.
Oh,
Did you figure out your problem?
no, but I figured
Okay.
out, I think, what I did wrong. I pressed the pause button earlier.
Oh, interesting. Well, so here's a tip for everyone. Actually, I'll show it on my screen in just a second. I'll show you. You saw that my game was turning purple every time I hit play. So that way I know that it's actually running. So yeah, I think that's all your problem was. Although once again, why is it invisible? Will you switch to 3D view for us? Yeah. So your camera, I think, got positioned incorrectly. Click on your camera, main camera. So its current Z position, this is a really interesting application, a really, once again, an interesting sort of result of this being a 3D game. The way that we handle ordering, so something appearing on top of something else in our 2D Unity games is actually Z position, how far away from the camera it is, which is why the default Z position of the main camera is -10. So you probably hit reset on this or just moved it. So change the Z position to -10. And this way, every time you add an object, it'll definitely be in front of the camera.
All right.
And now if you hit play, Mario should be good. Although I think you're missing some components.
It should fall through. Or did I not even add?
Nope.
I guess
Yeah, so you're missing your stuff. So
physics.
hit,
Okay.
yep, add component, rigid body 2D. There you go. And then add component, Capsule Collider. Same thing, same guy. Yep.
To the capsule. Okay.
Yep. Yeah, you'll wind up with like a million components on the same character, which is one of the limitations. But you want a Capsule Collider on him. So here's another tip for everybody. In the Box Collider component, so go down there, 3 little dots in the top right of the Box Collider 2D component. Yep, hit that and hit remove component. That's how you remove components if you ever add the wrong one. And then this time do a Capsule Collider so that the collision is more accurate to the character.
Oh, a capsule collider. Oh,
Capsule Collider. Yeah, you want a Box Collider on the box.
okay.
Yeah, it's okay.
Yeah.
Box Collider on the box and then Capsule Collider on the capsule. There you go. So this one wants a Box Collider. Yep.
So if I hit play now,
He should fall and land on it. All right, success. Well done. All right, will you stop sharing your screen for me? Perfect. Okay, so the thing I wanted to show you guys, which is actually pretty useful, you saw there that Miguel wasn't sure if his game was running or not. A simple way to fix that, Unity has a setting. If you go to Unity Preferences, actually, I already have it open. So Unity Preferences. I'm not sure if it's exactly the same on PC. I'll have to experiment a little bit. I'm on a Mac. In the Preferences dropdown, there's a couple of different categories, and somewhere around the middle is Colors. You click on Colors. And then maybe a third of the way down, there's this Play Mode Tint. This is going to be the color that your Unity turns whenever the game is currently running. So change that to something, they just have it as like the default dark gray, so you don't even notice that it's changing colors. So I would make it something dramatic, because then you know, like, oh, my game is currently running. So you can see mine turns purple, so it's a little bit more obvious that it's actually going. And for whatever reason, mine is reloading those assets every time, which is slowing me down, but that's okay. All right. Working here as well. Fantastic, Fernando. All right. So we have a character who falls and lands on our box, which means it's just about time to do some programming, I think. Yeah. Okay. So the next thing we're going to do is make it so that our character can jump and move. And we're going to do that by using the jumper and mover scripts that I already wrote for you. And then we're going to write our own script called an input controller. Before we even do that, though, we're going to do a brief intro to coding with a script called Hello World. Is anybody here an engineer, or do you know how to code? Nobody? Not one? I don't believe you. It's okay. Hello World, the reason I ask is because Hello World is a super, super classic example. Literally every programming language out there has a Hello World. So what I want you to do is down here in your project, remember this is all the stuff that's available to us to make the game. This packages folder for the most part is all the stuff that Unity kind of gives you to play with. And then the assets folder for the most part is going to be everything that you add yourself. So in your assets folder, hit plus and create a new folder. we're just going to stay organized. So I'm going to make a scripts folder. Scripts. Did I spell that right? Yeah. And then inside of my scripts folder, so with my scripts folder selected, I'm going to hit the plus button. I'm going to go to C# script. And I'm going to name this. We see that the script gets created and it automatically highlights the name. I'm going to name this Hello World, uppercase H, uppercase W. This is what we call upper Pascal case, which means the first letter of every word should be uppercase and there should be no spaces. In C#, that is what we expect for all of our scripts. Now, this is where hopefully I'm not going to lose anybody. If you double click on your script now, your default script editor should open, of which I recommend Visual Studio. It's the default with Unity, and it's still actually the one that I use after like 10 years or whatever of using this program. I just think that it's does a solid job, kind of gets everything that I need it to do done. If no script editor opened, please let me know now. Miguel, is that a joke? Oh no. So Notepad will work, but it will be awful. Oh, and Kenny doesn't have one either. So that's all right. Let's figure this out together. 1 second. So a script editor, if we look at my Hello World here, is just a text editor with some extra features. And the reason that a real script editor is really nice is because it will notice things for you. So if I type in some gibberish there, it will underline that in red. If I use Notepad, it will not do that. It will also not automatically indent when it should be indenting. It will not do a lot of things that will make your lives a lot more difficult. So for today's class, since we are already, getting towards the halfway mark, maybe you can just use Notepad++. Visual Studio is actually pretty small, so you could also just go download it. It's also free. You'll have to make an account. It'll put you a little bit behind, but if you want to be able to follow along as easily as possible, you might want to just grab Visual Studio. There's also other options. I personally really like Sublime Text as well. But you may even have Visual Studio. I would search your machine because I think by default it gets downloaded with Unity. And then this is I'm going to be sending out this recording. We are recording this class, and I'll be sending out this recording to all of you after the class, a couple days after, usually when it's done processing and we've got the time and everything. So you can always come back to this section and look at this again if you need it. But here's how you hook up a script editor once you have it downloaded. You're going to go once again to Unity Preferences. And then you will look for the External Tools option, just a couple down from Colors. And we'll see that the very top option is our External Script Editor, which in this case, I have external Visual Studio for Mac, which I think I'm actually behind on that. And you can hit Browse and find whatever you want to use. So for today's class, we're not going to be doing a ton of coding. It's always an interesting balancing act, trying to find like enough coding for you guys to feel like you get what's going on, but not so much that we're spending 10 hours talking about syntax. Notepad will mostly work, Miguel. It'll just like be a pain and you won't get why things are wrong sometimes. So let's jump into our Hello World script and let me talk about this a little bit. I don't want to spend too much time here. How many of you actually, this is an interesting question. How many of you want to be engineers? How many of you are doing this because you want to code for games? Okay, a couple at least, yeah. So there are a lot of, I don't know how familiar, many of you probably are not very familiar with the industry. There are many, many, many roles in the game industry. I, for instance, am not actually an engineer anymore. Thank God. I like engineering for the most part, but I like designing games more than I like coding them. So I'm what's called a game designer. That means I'm the one coming up with the actual core gameplay loop and the game systems. So I'm the one saying, this is what I think will be fun. And then I'm the one bringing those games to people and testing it. A game engineer is the person who's actually writing the scripts. Sorry, Fernando. I like engineering too. I'm just like, I don't have the brain for it. I can program for the most part. I can teach you guys who are beginners for sure. But once you start getting really advanced, I get lost. All right. So this is our Hello World script. Let me explain how C# works so that you can get a basic understanding so that we can write some of these scripts for us. C# is a language, a programming language. Unity is an IDE that happens to use the C# language. There are many languages out there. Java is one of the most common ones that you will see. That's usually actually where people start learning. Python, C, C++, C Sharp, and so many others. The C Sharp is what Unity has defaulted to. In the old days, you could use JavaScript. You can't really do that anymore. So for the most part, you're going to be programming in C Sharp if you're using Unity. In C Sharp programming, and in most programming languages, your code is going to be split into what we call classes. So if somebody says, I wrote 3 classes the other day, that basically means they wrote 3 scripts. Some of my explanations in these intro classes, by the way, are not holistic. I'm telling you kind of the simple version so that you get the concept without me going into too much detail. But for the most part, when I say I have a class, that means I have a script. And this script I named Hello World. Now this moniker here, public, is what's called our accessibility. That means who is allowed to see this thing, in this case, a class. And a public accessibility means anybody can see it. We may go a little bit more into detail later, but we don't want to bog you down. The next term here, this is our inheritance. This is who we learned from. So we, Hello World, know how to do anything that Mana Behavior knows how to do. Mana Behavior is a default script that the Unity engineers made for us that knows how to do a lot of different things. You don't need to know anything more about that right now. This is actually a much more advanced concept. Now, probably the most important, or one of the most important things to understand about pretty much all languages, some of them don't use it, but most of them do, is the humble curly brace. Can anybody tell me what a curly brace is and does?
It begins and ends code.
Yes, pretty much. I mean, that really is it. It begins and ends code. It's kind of like the first letter of a sentence and the last and like the period or the exclamation point of a sentence. So when I am looking at my Hello World script, I see an opening curly brace, which means it's facing to the right. That means that anything inside of this curly brace, all the way down to its closing curly brace, the one facing to the left, is a part of Hello World, is a part of this thing. So in this case, it's Hello World. If I look at my start function, which I'll tell you what that actually means in a second, it has its own pair of curly braces. So is stuff a part of my start function? Yes. Is stuff a part of my update function? No, because it's not inside of the curly braces, right? Is stuff a part of my Hello World class? Yes. So we can have nested curly braces. So we'll go into more detail on that. But for the most part, when you see a curly brace, the line above it is, it contains the line above it. So anything inside of it is the line above it, is the thing, is Hello World, is the start function, is the update function. All right. Now, we are not going to use the update function for this script, and we'll talk more about what that does when we get to our next script. But you can, so you can go ahead and delete that. Thanks, Unity. Why we gotta do that right now? All right, great. So we just have our start function for now. Now, one of the things that this Mana Behavior thing does for us is it has a couple of default functions available to us. Thank you, Unity, being very helpful. One of those default functions is this start function. Now, can somebody tell me what a function does? Fernando says grouped code. Great, good job, Fernando. What is a function? And whenever I ask questions like this, I actually very much encourage guesses. If you're totally wrong, we'll make fun of you. No, I'm just kidding. If you're totally wrong, we'll applaud your guess and we'll move forward. So a function is actually another sort of group of code. Kenny says it's an instruction. That's kind of right. It's another group of code. It's a thing that does something. So I might write like a public, I don't know, what's a good example? Int sum that takes in two numbers and then spits out number one plus, you guys do not need to write this. This is an example, and then we'll finally write our Hello World script. So this is a completed sum function. It has a accessibility identifier. I might need to change versions of Unity. It's weird that it does that so frequently. That means that anybody can see it, like I was saying. Everybody is allowed to use sum if they want to. Next, it has the type of thing that it outputs. In this case, it outputs an int or an integer, which is a whole number. It has a name. I named it sum. And then it has some parameters, the values that it needs to do its work. In this case, one integer and a second integer, which it then adds together and returns or outputs. So don't worry if not a lot of that made sense. I'm just trying to give you a sense of what a function does. So this is like a single thing. It's a single like piece of, it's a single executable. It's a single operation. It does something for us. So we might have a function that like makes our character jump, for instance. We do have that. We have a jump function. We have a move function. We have a shoot function, maybe. In this case, a sum function. So the big thing in code is that we need to know when our functions actually get called, when they actually happen, when the code in them actually gets executed. The start function is special in that it automatically happens. Unity makes it happen for us. It never needs to be told when to happen. And it happens one time before the first frame update, which to translate to English means when the game starts. When we first start the game, this is going to happen one time. So let's make something happen. You're going to write your first code inside of your start function, indented in, so we can see that I'm actually one tab in or 4 spaces, depending on which side of that fight you're on. I'm going to write debug with an uppercase D dot log with an uppercase L, parentheses, quotation marks, hello world. And then I'm going to put a semicolon at the end of that line. Let me make this bigger. Man, this is, I updated to the most recent version for this class, and I have not had this reload script assemblies thing happen before. So apologies if that's jumping in the way. That's some of the, like I was saying, Unity is really bloated these days. It's still such a powerful tool. It's still what I choose to make my games with, but because it's so bloated, it has weird eccentricities sometimes, and that's one of them, apparently. All right, so this is all you're writing. So debug is a static class. It's another script that they made for us that has a bunch of stuff that it can do. One of the things that it can do is a log function. The log function takes in a string, which is just text, and it outputs it to our console. So what we're about to do is print hello world to our console. This is the classic first programming problem. Write hello world to the console. So if I hit play now, I will see my glorious hello world message printed along the console. And I will be a proud programmer, and it totally didn't work and nothing got printed to the console. What the heck? Anybody know why it didn't work?
We never added it to the game, did we?
Aha, yes. Yeah. So we kind of like built a resource for ourselves, this script, but then we didn't utilize it. We didn't actually put it in our game anywhere. So this is the really interesting thing about Unity. For the most part, this is not always true, but especially as beginners, for the most part, whenever you make a script, this is actually a custom component now. This is actually a component that you're able to attach to your objects. So if I click on my capsule and I come down to add component, as long as you did everything right, if I search for hello world, that's actually an option that I can attach to my character. And if I click that so that my capsule has a hello world component, and then I hit play, the zoom controls are in the way if you're wondering why I keep dragging it all over the place. Let me put them over here. There we go. Hello world is printed to our console. You are all engineers. Congratulations. Now you can build the games that I don't want to build. All right, now this is a very important checking in point. Please let me know if you do not have this working, because there are a number of ways that you could run into a problem here. You should have a character that falls and lands on a platform, and you should have a thing that says hello world to the bottom of the screen. Just installing Visual Studio, Kenny, no problem. Like I said, this recording will go out to all of you as well. So you can, you'll be able to catch up on anything that you may have missed. And I'll give you some contact information for me too. I try to make myself a resource for people because I've had so much help myself. The thing I have not been able to do is any of the scripting. All right, Colleen, you will have to, in just a second, we're going to write code that will make your game work. So it is important for you to figure out how to open up. You can just open it up even with text edit. That may, if you have a Mac, text edit, or Notepad if you have a PC, which will let you do stuff. The other thing is you can use Notepad then. The other thing is I gave you that resources folder. Any of the, where are we? Here we go. In the scripts folder, we'll see that all of the scripts that we're going to use are here. And we'll see that some of them say completed. So this says completed player controller. That is actually the same script that we're about to write. So you could download this and just use this script if you wanted, if you can't get your coding to work right now. Okay. Everybody else good? Got stuff printing? Fantastic. Well done. I like that solid thumbs up, Justin. All right. Now let's do one last thing. The sort of the core 3 pieces of code. We have classes, which are whole scripts. We have functions, which are a single sort of a single function, a single thing that does something. And then we have variables. So under this first curly brace on line 6, I'm going to add a new line, and I'm going to write public string text to print equals, actually, let's not even default it, text to print semicolon. Now you'll notice that this time I did lower Pascal case, also known as camel case, where the first letter is lowercase, and then after that, all the first letters are uppercase. The reason that I do that, this is just common C# syntax. The reason that I do that is just to make it easier to identify that this is a variable, which is the third thing that I'm talking about here. A variable is a single piece of information that we are saving of a specific type. So who remembers what a string is?
Text.
So this is a single piece of text that we named text to print. Now here is the cool part. If I copy this and I paste it into this text box down here and remove hello world and just put text to print, Unity will not complain. They'll be like, great, that makes sense. Once it reloads my script assemblies for the 17th time. And then if I come back to Unity, here is where stuff gets really cool. If I click on my capsule and I come down to hello world, suddenly I have an open text box called text to print, where I can type in anything I want. Now, when I hit play, Unity will automatically print that to my console. Anything I want. There you go. So that is a variable, a function, and a class. Anybody have an issue?
Can I reuse it and, I don't know, to another component and change the
Great
text to
question.
print?
Yes. So this is exactly why you might do something like this. Instead of manually writing in, this is what we call hard coding. When I hard code something, no matter how many times I use this component, it's always going to type hello world, which makes it not very flexible. Instead, if I do this, and by the way, I can also default this value, which is what I was just questioning if I should show you, but I might as well. Instead of just leaving it like this, I can put an equal sign here and set it equal to anything I want. And this will be the default value that appears in the inspector. But I can add multiple versions of this component to anything I want, and none of them will care about each other. So I could even add 2 hello worlds to the same component. I could have 2 hello worlds on Mario, anything I want, and hello world. And now when I hit play, both of those will do their work. Both of them will print to the console. Here we go, hello world and anything I want. Now this is one interesting little note, by the way. It wrote hello world before it wrote anything I want. So it got to this component before it got to this component. You actually cannot guarantee which of these will happen first, which is something you will need to care about when you're more advanced. All right. Anybody need me to pause, or are we ready to write a real script and make Mario run around? In the second half of the class, a lot of stuff starts happening quickly. We're going to write one more script, the player controller, and then everything else is just dragging and dropping stuff that I've already written for you. All right, here we go. So you can, depending on what you want, you can remove these components now. They were just to show you some of the basics of code. So once again, if I want to remove a component, I can go to the bar that says its name, Hello World script, 3 little dots, remove component. I can do that for the second one as well. I am going to do that because I don't like having needless messages in my console. But if you like them, if they make you happy, go ahead and leave it. Now we're going to make our Mario move and jump around. And there are, oh, let's actually, before we do that, let's make Mario actually look like Mario. So the Mario Into Hours resource folder that I sent you, and I'll send this one more time since I sent this so long ago. Here you go. You're welcome to use anything in here. There's also a handout with some extra homework and good stuff like that. Inside of here, there's an images folder. You should be able to just right click and download the whole images folder. But if you're having problems with that, like some people don't have a zip utility, you can always go in and download just one image at a time, and that'll work too. It's just a little bit more annoying. And you can always, for the sake of this class, probably, let's not open that up. Great. You can go and find your own images. So you can go and find, like I was saying, a vampire or something, whatever you're making in your game. But for the sake of this class, I'm just going to use the example images that I already have. So I have these images that I want to be able to use in my game. In order for me to import them into Unity, this is another one of those things that's just like so nice. It's just so simple. Literally, all I have to do is drag and drop into my project. So I'm going to select, actually, I'll just drag the whole folder. That's all right too. I'm going to click and drag the whole images folder right into my project under my assets. And when I let go, oh, it didn't like that. That's new. Interesting. I guess I can't do whole folders anymore. That seems dumb. It's okay though. I'm going to make a new folder then, and I'm going to call it images. You can see that even though I've been using Unity for 10 years, they change things often enough, and there are so many features that there will still be things you have to Google forever. So, you know, don't be scared of that. Asking for help building games is totally normal. So instead of getting the whole folder, I'll just have to shift click and get all of them. And then I can click and drag into my images folder here. Make sure that the images folder is highlighted, you can see. And when I let go, Unity will actually duplicate these images. So these are not being moved. Unity is actually duplicating them and putting them into your project. And you can see that now I have 5 different images of these different characters that I can use. Let me know if anyone is having issues. All right, to make our capsule look more like Mario, we're going to click on our capsule. We're going to go to our sprite renderer component, and we'll see that this sprite box currently has capsule in it. There are a couple of different ways. Whenever we have an empty box like this, so we can see capsule, or not necessarily empty, but whenever we have like a space like this, like sprite's defaults, the same kind of thing, or our material down here, we have a couple of ways of editing that thing. So the first way is to drag and drop. So I can drag this actual Mario image and drop it into that sprite box. And we can see that it automatically changes the image. We're going to have to do some editing to get the size right now since we changed the image. But Mario is now on my screen. The other way to do it, so just dragging and dropping, literally. Whoop. Nice. The other way to do it is this little circle on the right-hand side. If I click that, it'll open up a dialog box with all of the options for this thing. So you can see Unity actually has some default sprites available to you. This weird little owl, if you want that, you can use it. It has a couple of other things, but if I go looking, we'll find our Mario eventually somewhere in there. Actually, I learned this recently. Yeah, in the top right, you can see that there is a click to toggle packages visibility. It'll actually hide all of those default Unity things if you want to hide them. They're relatively new. It used to not give you any of those. So it's kind of nice for beginners, but kind of annoying once you know what you're doing. All right, so we have a Mario. He's way too freaking big, and his capsule is totally the wrong size. So we're going to have to do some editing. First of all, we can use our scale to get him to the right size. So he's like a giant. So let's try 0.1. Oops, 0.1. That actually looks maybe about right. We can decide, you know, how big we want our character to be relative to the space the player has to use. But we'll see that now that I did that, the capsule actually was affected by scale. So the collider is currently tiny, which means if I hit play and wait for it to reload script assemblies, Mario will fall and he will successfully land, but we'll see that it's that capsule that actually matters for collisions. So it's not hitting until that capsule hits. So in order to fix that, we can do a couple of different things. Number one, this is going to be the most common thing you do. Whenever you change your sprite, you're probably going to have to do this. Go to your Capsule Collider or whatever collider you have on this object. Go to your collider component, go to the 3 dots and hit reset. And it'll once again do its best to fit the shape of this image. Unfortunately, this time it didn't do a very good job because Mario's just kind of a weird shape. So you can see, once again, that green circle is where he's actually going to collide. So there's a lot of extra space where Mario will run into stuff, even though it won't look like he should. So you can mess with some of your values, your size in particular here, in your Capsule Collider component until it looks a little bit better. So maybe like a 7 or maybe even a 6. Yeah, 6 looks about right. So now it's really wrapping around Mario. And then his feet, this doesn't look like it's going too far, but he will wind up floating a little bit, which will look a little bit weird. So I'm even going to make his Y a little bit shorter too. Yeah, that looks about right. Maybe even less than that, honestly. There you go. Little juiciness tip for you. It's actually often good to give the player some extra space. So even though Mario's feet are not currently covered, maybe it's good that the Capsule Collider doesn't cover them to give the player a little bit of extra leeway. Okay, now let's do the same thing to our square. And actually, let's rename our capsule to Mario or to player, whatever makes sense to you. We do that by clicking it, and then in the inspector, go up to the top, and we'll see it says capsule. I'm going to change that to be player. When I name things, when I name pretty much anything, my scripts, my objects, my game objects, I try to make it as robust as possible. So if we decided that Mario wasn't our player anymore, and we wanted this to be about Sonic the Hedgehog, I wouldn't need to rename this to Sonic the Hedgehog. Player as a name still works. Colleen says it doesn't let you rename anything. That would be very odd. What you should be doing to rename stuff, Colleen, is to click on your player. Maybe your game is running. Actually, I think even then it would let you edit the name. Let me check though. Yeah, even then it should work. So let me just make sure you're doing this right. Click on your player in the hierarchy. Over in the inspector, there's a box at the very top. Just click on that, name it anything you want. But I think it should be player. Let me know if you're having issues. We can always screen share with you. I'm going to do the same thing to my square. I'm going to name this platform. And I'm going to change the square sprite to the platform sprite that I got, the brick. And once again, that's kind of huge, so we could make that a little bit smaller. And once again, we probably need to change the size of our box collider by clicking in the 3 little dots and hitting reset. Colleen says, still nothing. All right. So I'm going to have, Colleen, are you comfortable sharing your screen so we can try to fix it? All right. So in just a second, I'm going to ask you to do that, Colleen. For anybody else, while we are helping out Colleen, you can go ahead and start duplicating your platform and start to make a little level for your Mario. So you can click on the platform itself and either copy and paste in the hierarchy to make multiple, you can see, or you can hit Command D on a Mac to duplicate, or Control D on a PC to duplicate.
Is there a snap to grid option?
Yes. Do I remember it though? I think, let me try this real quick. I think it's this. I believe it's some combination of using the V key. So you'll see that if I hold V while I'm moving stuff. Yeah, there you go. Yeah. So this is not a tool I use tremendously often, but it does seem to work. So if I before I move my object, if I hold V, we can see that I can select any of the corners or the center, and then it will try to snap to other vertices that it finds. All right, Colleen, go ahead and share your screen for us. Okay, so you have your capsule there. Great. By the way, you guys should be saving as often as you can. So on Mac, that is Command S. On PC, I believe that's just Control S. Perfect. So that saves your actual scene in case Unity crashes. You don't want to lose your progress. So Colleen, in the inspector over on the right-hand side, yeah, click that. Huh. Weird. I've never seen that before. Oh, perfect. That's really weird. I would, you know what you can actually do? So it's bizarre this is not working. I would spend more time trying to figure it out with you. But probably this is a tip for everybody. If you're running into a problem with Unity that really doesn't seem like it should be happening, like probably I should be able to rename this object. Sometimes try just restarting Unity and it will fix it. For the sake of this class, Colleen, I can show you a different way to rename stuff. So if you go over to your hierarchy, you can right click on any object like your Capsule Visual Studio IDE and hit rename. Yeah. Oh, and it still doesn't let you. That is so weird. All right. Well, you can either live with it. It's not a big deal that it's not the right name for today's class. Or you can try restarting and you'll just have to wait a little while. That's very strange. I haven't seen that before. You might have some, I swear when I'm working with new people, I run into more problems than I have ever had in my life. So it may just be that you have some interesting option on that I'm not aware of or something like that. But yeah, so either try restarting or just like deal with it for now. It's not a big deal that it's named incorrectly. It's not going to break your game. Okay, so you can stop sharing. Thank you so much. Let's jump back in. All right, so we've got a Mario. Mario can do can fall and land, but let's make Mario actually move. So currently, we only have our Hello World script. Go ahead and go into the scripts folder, and you can download this whole folder as well in the assets that I sent. Wait for that to zip up. Great. And then same thing that you did with your images, you can just drag and drop them into your folder. Stay organized. For this class, just a 2-hour-long game, it's not gonna, you're not gonna get too disorganized too quickly. But it is amazing how many things you need to make a game work. So try to stay as organized as you can, make subfolders, all that good stuff. You can grab all of those scripts and you'll see that there are a couple of completed scripts in here. When I used to run this class, I was very ambitious and I tried to get my students to write 4 different scripts in one class, and that was too much. So we are only going to write the player controller. That's going to be the last script that we write today, which we're going to write in just a second. So download those scripts and import them into your script folder. Now, the other way that we do these classes is we get to a different point pretty much every time I run this. So sometimes we'll get through all of my material and we'll invent new stuff to do together. Sometimes we won't even get to the point where Mario is walking around. So just try to stay patient. There are extra resources that I have available that I will send you in the follow-up email for anything that we may have missed or anything like that. It's just kind of how the class goes. It's quite a lot to ask people who have never used this before to make a whole game in 2 hours, but that's kind of why this is fun. All right. So here's what we do to make Mario jump and stuff. Also, I am missing my chat. Let me make sure I'm not. Can I make the square transparent and still apply the box collider? Yes, that's a great question. So if I click on my platform, any object, we'll see that in the sprite renderer, it has a color. And if I click on that color, we have what's called RGBA, the amount of red, the amount of green, the amount of blue, and the amount of alpha, which is how transparent this thing is. So I can change that alpha to make this, this thing more or less transparent. And the collider doesn't care how transparent this thing is. So even if I made it an alpha of 0, so fully transparent, Mario will still be able to land on that platform. which right now, nice. We'll talk about how to fix that in a second. Right now, it looks like he's just landing on this one, but I guarantee this still has collision. So that's an extra little option for you. All right. So let's make Mario actually move around. On my player object, or my Capsule Visual Studio 2D object, whatever you named it, I'm going to go down to Add Component, and I'm going to find my mover, which is a script that I wrote for you. Something that I recommend you do later, now that you have a rudimentary understanding of how code works, is to open up some of these scripts that I wrote for you and start to look at them. I left a decent amount of comments, so you can try to figure out how they work. Maybe play around with them, maybe mess with them, maybe break them. If you break them too bad, you can always just get the script again from the assets folder. That's one of the best ways to learn. So I'm going to add a mover and a jumper. I want my character to be able to move and jump. However, this is not going to work. Just like our Hello World script, these things need something to trigger them. And if I open up, let's open up my jumper, for example. My jumper does one very simple thing. It accesses the rigid body, the thing that knows how to do physics, and it applies a force to it. My velocity adds a force. I'm not going to say much more about this right now for the sake of time, but basically the jumper just knows how to jump, knows how to make Mario go like this. So this jump function doesn't happen unless we tell it to happen. The reason our Hello World script happened is because it was in our start method, which automatically happens. Unity tells this to happen at the beginning of the game, right? The jump function will not happen unless we tell it to. So we're going to write our last script for the day called our input controller. And that'll be the thing that actually tells our mover and our jumper to do stuff. So come down to our scripts folder and hit plus C# script and write input controller. Oh, I named it player controller before, but I don't know, whatever. You can name it either player controller or input controller. And the script that we're about to write is going to be exactly what the completed player controller is. And in fact, the completed player controller has some extra features. So I think it plays sound, for instance. Yeah. So this is something that you could look at later, or if you don't want to code right now, or if you can't code right now, you can just use this completed player controller script. But we're going to write our own so that you have a better concept of how engineers actually approach building games. So our input controller is going to do something very simple. It's going to listen, is how we put it, for input. And if there is input, it's going to tell the mover or the jumper to do their work. So once again, we're discretely splitting up our components. There's one thing that listens for input, and there's one thing that knows how to jump. Those things don't know how to do each other, but they do talk to each other. So the input controller is going to tell the jumper when to actually do its thing. So we need a couple of things to happen in that case. First of all, we need to hook up. We'll start with the jumper because that'll be a nice and easy way to start. We're going to need to hook up the jumper into the input controller. This is the easiest way to do this. This is not always the best way to do this, but it's the easiest way. I'm just going to add a new variable with a public accessibility of the type jumper. That's right. Our scripts can also be variables. And then I'm going to name it whatever I want. One of the simple ways that I do this to try to make it clear for beginners is I call it my jumper. So this is going to be the Mario's jumper, right? So this is how we're going to hook it up, and I'll show you how to hook it up in just a second. Boy, that's really fun. And now we're going to use this jumper now that we have access to it. And we're going to use it in our update function, actually. So I'm going to type out a decent amount of stuff right now. Just copy me, and then I will tell you what it does. I'm going to write if parentheses input dot get component. Sorry, that's not what I meant. If input dot get key down key code dot space. Now, by the way, this key code is the button that it is listening for. So if you wanted to make your up arrow your jump button, you could change this to up arrow. If you wanted to make W the jump button, you could do that too. And then I'm going to put in a set of brackets. And I'm going to say my jumper dot jump with parentheses and a semicolon. So copy that all down. I'm going to give you a second, and then I'm going to start talking. All right. Now, just to be clear, uppercases, spelling, etc., punctuation, very important in coding. A computer has no way to guess what you meant if you misspelled something. You have to be very explicit. The only thing that doesn't matter is actually white space, so spaces or new lines. The computer actually does what's called compiling before it reads your code, which means it kind of condenses everything in a way that makes it easier for it to read. And when it compiles, it wipes out all the white space. So if you want, you could write like that, and that would be fine. It would just be terrible to read. But everything else needs to be exact. If you miss that, if you write like that, your code will not work. And we'll do an example error in just a second. So here's how this works. We're using what's called an if statement or a conditional. An if statement also gets its own set of brackets, just like a class or a function. If statements, this is now example code. You do not need to write this. If statements do something very simple. They say, if the thing inside of my parentheses is true, then I'm going to do the stuff inside of my brackets. So does 5 equal 5? Yes. So we're going to do stuff. Is 5 greater than 5? No. 5 not greater than 5. It's equal to 5. So we're not going to do stuff. Is 2 greater than 5? No, we're not going to do stuff. So that's all a conditional is. It's just a, will we do this? Yes or no. So we're saying if we have a key that has been pressed of the type space, so this is the space bar, then we're going to do stuff. Then we're going to tell our jumper to jump. Now, this is how we remotely tell a function to happen. If you remember, our jumper has the jump function in it, right? Whoops. The jump function doesn't require parameters. If you remember, our example sum had like an int in here and stuff. The jump function doesn't need to know anything. As long as we tell it to jump, it knows how to jump. So all we do is we say, hey, my jumper, the jumper that we just hooked in, I want you to jump now that the space key has been pressed. And the way this actually works is through what the update function does. Anybody guess what it means when this thing says update is called once per frame? Or can you explain that?
To be called all the time, multiple times while the game's running.
Exactly. If you guys weren't aware, you probably have noticed this. When you're playing your games, you have a frame rate. For the most part, depending on how sexy your gaming PC is, your frame rate is going to be somewhere between 30 and 120 frames per second. Unity defaults to try to hit 60 frames per second. So that means 60 times per second, update gets called. If we put, which we could do, you might do it just to see what happens. Once again, it's one of the best ways to learn. Stuff. If we put stuff in our debug, just like our hello world, 60 times a second, update is going to print out stuff into our console. So what this is doing is 60 times a second, it's asking if the space bar is pressed. So 60 times a second, it says, is it pressed, is it pressed, is it pressed, is it pressed? Whenever it's pressed, keycode.down, it makes our character jump. So let's go back to our game and click on our player. We now need to attach this script that we wrote. We can come down. You can see this is one of the limitations of component-based programming. This gets really big really quickly. One of the tips for you is that these little tiny gray arrows are actually drop downs. If you click on them, it makes it smaller. I'm going to add component, input controller. And we'll see that the input controller expects just one thing, a jumper. Now, a really common rookie mistake is that you're going to try to drag and drop the jumper script from project into this spot, and you'll see that it doesn't even accept it. What this actually wants is a jumper that exists, that is already in the scene, which means which one are we probably talking about? Literally that one right there. So you can actually just drag and drop this component right into that slot. And now we have successfully hooked up the input controller. Now the input controller knows about this jumper. It knows which jumper it's supposed to be talking to. And now if I hit play and I've done everything correctly, Mario will fall and land on the platform. Oh, I got to fix that first. All right. I'll give everyone 1 second to catch up. I'm going to switch this platform to not be invisible. Okay. All right. So the reason that Mario, actually, can anybody tell me why is Mario rolling?
I can't add my input controller script to the player.
You got a bug. We'll do that in just a second. So let me show everybody how to fix this really quickly. Mario is rolling because he has a round bottom. I came out wrong. There is a round bottom to the collider. This is actually a really nice thing to have in most cases because it helps stuff from getting stuck. So if there's like, imagine a little tiny lip and Mario had a square collider, he would run into that tiny lip and get stuck. With a round bottom, it'll kind of adjust for that more naturally. But a negative of it is that he'll fall over very easily. However, Unity has a very easy way to defeat that. So if I click on my player and I go to my player's rigid body, I want everyone to pay attention here for a second, because this is one that I have to tell everybody like 3 times. Click on your player, click on your rigid body 2D. Go down to constraints. It's another drop down. Click that drop down and you'll see a freeze rotation Z. Click that sucker. And now Mario will not be allowed to rotate unless you manually rotate him with code. So now he will fall and land on the platform in just a second. There we go. And once he's on that platform, if we hooked everything up correctly, I should be able to hit space and Mario will jump. Hallelujah. He can also jump to the moon, but we won't worry about that right now. All right. So Miguel, you almost certainly have a bug. Is there something being printed into your console?
No, there's nothing. I mean,
It doesn't say anything in your console?
I mean, when I run the game, yeah, no, there's nothing.
Does it say something in your console when you aren't running your game?
No, not at all.
Okay, let's do a screen share again. See if we can fix it.
All right.
Look at that, looks fine. Will you double check that your script is saved? It's another common one.
Okay. Yeah, it's saved.
Okay. Oh yeah, you can actually tell. Here's a good test for you guys. You can see in the inspector that it actually does a preview of the script, and you can see that he's got all his script in there. It does look correct. Okay, and then click on your player and click Add Component and search for Input Controller. Okay, so I bet I know what's going on here too. I do know what's going on. All right, so this is a really common one. You can stop screen sharing because this is another common one that I should explain to everybody. So this is just one of those like gotchas that happens to everybody who starts in Unity. I'm not sure why exactly they did it like this, but they did. So here's what happened to you, Miguel. You have 2 different names for your script and Unity doesn't know what to do about it. This will make more sense when I show it. So in my project, my input controller says input controller, but let's say I accidentally misspelled it and I named it input control. If I go to my, if I wait for it to reload script assemblies, never using this version of Unity. Oftentimes stuff like this will get fixed in the next version. So I will, if I come and look at my script in Mario now, you can see that I'm having the same issue. It's like, wait, what the hell script are you talking about? There's nothing called input controller. The reason that you might think that there's only one name, but there's actually 2. If I open up this script, that is a separate name. There are 2 locations. This is another important one that you will all make a mistake with at least once. There are 2 locations you have to rename a script, and those 2 locations must be exactly the same. The name of the file, which is what's in your project, and the name inside of the script itself, the name of the class. These 2 must be exactly the same. So what I noticed for you is that your input controller has a space in it, which you should never have spaces in script names, by the way. So what you probably need to do is, oh God, come on. wait for this to go. What you probably need to do is rename this, delete that space, and then double click on it after you rename it. Otherwise, mono behavior will edit an old version of your script that no longer exists. I know it's annoying. This is what we deal with in the industry. Once it actually opens up, which it is trying to, I guess, we can see that it actually has the old incorrectly named thing here, even though it no longer even exists. That's what I'm talking about. So make sure you open the correct one by double clicking. There we go, finally. And then make sure this is exactly the same as well. And did you do that?
That was exactly the problem. I had a space on my name.
Yes. All right. So let's make our input controller. Does everybody have their input controller jumping? We got a little jumping Mario. Fantastic. All right. So we are coming close to the end of time. No worries, everybody. I'm going to have us do the simple version. We're, for instance, not going to have Mario flip back and forth, but I'll tell you that this line right here, the sprite renderer, doing a flip X is how Mario turns back and forth. So you can look at the completed player controller after class to make your game more advanced. But let's do the simple version now. So I'm going to do the same thing. I'm going to make this is my input controller again. I'm going to make a public mover. And then I'll do the same thing. I'll call it my mover. And then in update, I'm going to make two more if statements. I'm going to make a if input dot get key dot left arrow. And actually we can just finish this so that we can copy and paste it. I'm going to say my mover, and this is going to look really weird at first. I will explain it in a moment. My mover dot, I believe the function name is accelerate in direction. Let's see if I'm right. New vector 3, -1f, 0f, 0f. Zoom back out. All right. Yep. Nailed it. All right. That is what you're writing down. And then I'll explain it when you get there. If input.get key, not get key down. If input.get key, key code left arrow, my mover.accelerate in direction, new vector 3, -1f, 0f, 0f. Once you have all that, you can actually copy this entire block because we'll do the same thing for the right arrow. So now that I've copied the entire block, I'm going to change it from left arrow to right arrow. And I'm going to change this -1 to a +1, which I'll tell you why that is in just a second. We have a chat. Nice. All right, I'm gonna start talking. Don't worry if you're still copying, go ahead and keep copying. And like I said, your completed player controller also has this stuff, so you can also just copy and paste from there if you're falling behind or feeling confused. I have been building games since I was like 15, so I've had some experience. Don't worry if you're still confused, it's okay. Part of this, I think, is just beating your head into a wall until it works. All right, so we're doing basically the same thing to check if a key is pressed. The only difference is that we're using the get key function instead of the get key down function. For the sake of time, I'll just tell you that this get key down only happens once. The first moment that the key is pressed, it gets activated. And so we jump. But it doesn't do it after that. So if I hold the key down, we're not going to keep jumping. Get key keeps happening as long as the key is pressed. So now if I hold the left arrow, Mario will continue to move to the left until I let go again. Then we're talking to our mover instead of our jumper, and we're using this function called accelerate in direction, which does take in a parameter like our sum function. The parameter that it takes in is a vector 3, which we're just making a new one right here. So before, you remember, we would have made like a public vector 3 stuff, but we don't need to do that. You can make a function anywhere. So, excuse me, you can make a variable anywhere. So I just made a vector 3 right here because we only need it for this very brief moment. A vector 3 is sort of two things at once. It's an X, Y, and a Z. So you can think of it like a coordinate somewhere in space. But it's also more accurately actually an arrow in space. So if I have my axis, X, Y, and Z, my vector is actually an arrow pointing somewhere in three-dimensional space. And it uses that X, Y, and Z with a start position of 0 to indicate where it's pointing to. So by making a vector with a -1 as its X, we have an arrow pointing to the left. And by making a vector with a +1, we have an arrow pointing to the right. So all we're doing is we're saying, hey, accelerate to the left and accelerate to the right. If we come back to Mario now, and as always, please let me know if you're having issues. We're going to do some rapid fire here to try to get as much in by the 9 o'clock mark as possible. So you may lose me here. Don't sweat it. We're going to have recordings and I'll give you contact information. You can always reach out. All right. As with the jumper, we have our mover here that needs to be hooked up. I can do the same thing. Click and drag my mover into that empty slot. And now it should work. This is going to be a little bit iffy. The mover script, I've actually never loved. I still use it. I don't know. I've never taken the time to fix it. You're going to need to play with the values on your mover, your acceleration, and your maximum speed to get Mario to really move correctly. Oh, actually, 10:15 looks fine. Nice. Not bad at all. But yours might not work quite that way. One thing I want to point out really quickly, if I change this acceleration to, let's say 5:10, I want Mario to move a little bit more slowly. We can see he's much more sluggish now. And then if I hit play and I stop playing my game, you can see that my values got thrown out. It's back to being 10 and 15. Unity does that on purpose. If you modify anything in the inspector while the game is running, it will throw it out when the game stops. And the reason it does that is to try to allow you to like play with the game without, worrying about breaking your game. So that's another important reason to have your play mode tint work. But that's actually all you need for a working Mario. He now moves back and forth and he jumps. Fernando's Mario is rolling. So that's the rigid body. Fernando, I told you, I said it. I said I was going to have to tell this room twice. Didn't listen. All right, Fernando, click on your player. Click on Mario, go to your rigid body 2D, go down to your constraints, which is a drop down. So you'll have to actually drop it down and click freeze rotation Z. This will make it so that Mario is not allowed to rotate unless we manually rotate it with code. Basically, it just tells the physics to not do rotation. So now he slips and slides instead of rotating. All right, so we have a Mario who moves around. Like I said, I'm going to be a little bit rapid fire here. This is actually the end of the part where we do any coding anyway. So that's the last piece of script that we're going to write for today. Like I said, it's hopefully like just enough for you to grasp what's going on so that you can continue to experiment and continue to learn. But we want to get a little bit more happening in our game because our game is pretty empty. So I'm going to just very quickly dupe some platforms so we have something going on. One thing that you definitely want on your main camera, you're going to want to click on your main camera, go to add component and add a follower script. So this is going to be the thing that tells the camera to follow your player around so that you can explore a much bigger world. You can see that the follower script has a, trying to stay awake here, it's 2 a.m. Probably missed. Getting back to that. No problem, Fernando. You're doing great, man. It's only 9 for me. You're rocking it. All right, so your follower script has a followed transform. That's just the thing that it's going to follow. In this case, we want it to follow our player. So I'm going to put a follower script onto my main camera, follower component onto my main camera. And then I'm going to click and drag my player into that slot. And now the camera will automatically snap to the player's position and stay there. So wherever Mario moves, the camera is now going to follow him. In a more advanced version of this script, we might give it some like dampening so it kind of moves with a little bit more sway. But for the simple version, it just follows his position exactly. So now we can have a much, much bigger level because it'll actually follow Mario wherever he is. And by the way, the jumping to infinity does get fixed if you use the completed player controller. Oh, you know what? Actually, I think the jumper does that automatically. So if you want, click on your player, click add component, click ground detector. This thing detects the ground. So if I hit play, now Mario will know whether or not he's on the ground. So this is an example of like really interesting ways that components hook up to each other. Now Mario knows whether he's on the ground or not, so I can no longer jump when I'm in the air because the ground detector is reporting to the jumper, hey, we're not on the ground, so you shouldn't be able to jump. And that's only the jumper and the ground detector talking to each other. The input controller has no idea about that. The input controller just tells the jumper to jump, and the jumper's like, nope, I'm not supposed to jump right now. All right. Feel free to pause me if there's anything you want me to go over again. Like I said, this is kind of rapid fire round. Why do we define the vector as vector 3? That's a great question. There's no real reason to have it be a vector 3 versus a vector 2. We can actually use something literally called a vector 2. And in fact, I may have been supposed to show you it as a vector 2. It does look like I used a vector 2 in the completed player controller. I just kind of did a vector 3 because that's what I generally use. This is, we now know how our z-axis gets used in a 2D game. It just gets used for closer or further from the camera, which the camera doesn't even detect. So it's more like ordering. If our z is further ahead, a thing will appear in front of the other thing. So all this will do, in fact, in this case, I think it won't do anything because I think the mover turns it into a vector 2. Yep. So in this case, it actually wouldn't have even, yeah, it wouldn't be a bug. It wouldn't break anything. The mover would actually just ignore the z. Even if you put a huge z in there, the mover would be like, I only need a vector 2. I'm not going to look at the z. That was just me writing it that way. So you could change this to a vector 2, which would mean you only have an x and y, and that would work just fine. I'm not going to do that because that might confuse some people. All right, let's add our flag to the game. Probably the most important thing. Oh, yeah, let's do the flag, and then I'll show you one or two other things. So a last hot tip for you, instead of having to add a new sprite and then change the sprite to the one that you want, I can actually click and drag any sprite from my project into my scene. And Unity is smart enough to make a new game object and to attach the flag as the sprite. It's a bit humongous, but I can make that a bit smaller in my transform here. Actually too small. Say 0.3, 1, 0.5. I don't know. You can play with it until you have a size that feels right. That looks about right. 0.2. Then I am going to my flag, I'm going to add component. And there is a completed flag script. It's only called completed flag basically because this was something that we would have written ourselves, but it just, anytime I try to do it that way, it's way too much to try to get done. So I usually just have people use the completed version of the script. Now, the completed flag script is expecting a win screen, which is actually a piece of UI. The player jumps out of the platform. Will the camera follow it into the bottomless pit? It will indeed. It will always follow the player as long as there is a player to follow. So the camera will just follow Mario into the void. Now the flag script is expecting a screen to actually show. In our case, because we're basically at the end of time, I guess here, I will show you the very quick version. The reason that I'm a little hesitant here is because UI in Unity is actually a pretty big concept. There's a lot to it, but let's do the very simple version. So in the top left, I'm going to hit plus. I'm going to go to UI, and I'm going to go to panel. And we'll see that a blur kind of thing, opaque something, appears over the screen in my game. And this massive panel appears in my scene. I've never really understood why they did it this way, but they did it. When you edit UI, for some reason, it's humongous. Don't know why, but it will look correctly. It will look correct for the position of the screen. There's other ways to get around this, but we have 7 minutes left, so I'm not going to tell you. This panel is going to be our win screen. So you can rename it if you want, except you, Colleen, you're not allowed to rename things. And then my windscreen, I'm going to click on it. And this is going to be another new concept for you. Like I said, I recommend you come back here if you're confused, or you reach out if you want to talk about how stuff works. I'm going to click on it. I'm going to click the plus button again. I'm going to go down to UI again. And this time I'm going to go down to text, which, yeah, we should be able to use Text Mesh Pro and not have weird problems. New version of Unity problems. Hopefully this is quick. You can hit import Text Mesh Pro essentials. You don't need the extras. There we go. We have a piece of text. But this actually did it slightly incorrectly. And this is where the new concept comes into play. So we can see how a canvas got created when I made my panel, and then so did the panel. And that the panel is indented from the canvas. This is what's called a parent-child relationship in the hierarchy. So basically, the windscreen is a child of the canvas. The text should also be a child of the windscreen. And I can make it a child by clicking and dragging it onto the windscreen. So I'm going to click and drag my text and drop it on top of my windscreen when I get kind of this gray selection. And if I let go and I see that the text gets indented, that's how I know I did it correctly. So now the text is a child of the panel. And the reason that matters is you can see if I move my panel, the text moves with it. So that's how you make more complicated objects in Unity. So for instance, our player currently has 1 million things on it. We may at an actual studio, we may have split it up so that we have one like parent object, and then we have maybe a sprite child, and then we have like the input controller child. It sort of depends. Many different places will do it different ways. For the most part, just do it the way that makes sense to you. And I actually, for many of my games that I work on these days, I still do it this way. Because until you make a very advanced game, this is still pretty manageable. This is fine. All right. So our windscreen is the thing that's going to tell us we won. We have text underneath it. And if I click on the text and I go to my inspector, we'll see that my Text Mesh Pro has a text box in it. So I can type, "You won." Amazing. You can change size. You can change the size of the box. There you go. All right. Now, the reason that I showed you this is two things. So I actually want you to click on this panel. And then in the top left of the inspector, there is a little checkbox right next to the name. You can click that and your panel will disappear. That is what's called setting active. You have set your panel to be inactive. It still exists. And we can actually see it in the scene as this grayed out windscreen or panel, depending on what you named it. But it no longer interacts with my player. The player can't see it anymore. That's what you want to do. So turn off your windscreen and then click on your flag. And we'll see that the windscreen has this empty object right here. You can now click and drag your windscreen into that empty slot on your flag. And then you'll want to add component to your flag, a collider, so that Mario can actually touch the flag. And as always, if you double click on an object, you will zoom in on it. And I think, let me check the flag real quick. Yes. So here is one last note for you. If anybody needs to go, feel free to go. I'm going to stay an extra like 5 minutes to make sure you guys have this. And then I want you to have the piranha plant as well, because it's kind of an interesting relationship. And then we'll call it done. Okay. If you click on your completed flag, if you look into the script, you'll see that this says on trigger enter. Some things will say on trigger enter, and some things will say on collision enter. That is a special function that means when I run into something. On collision enter means when I run into something, I'm going to do something. On trigger enter means when something passes through me, I'm going to do something. And it requires, this is another just sort of weird relationship in Unity. I don't quite know why they did it this way. It requires that on your flag, you go down to your collider and you change this so that is trigger is selected to true. You have to click this, otherwise your flag will not work. Your trigger, a trigger and a collider are actually two separate things. I think they should probably just be two different components, but you know, the Unity engineers did it this way. A collider is something that runs into something like our platforms. A trigger is something that's just meant to be there to like indicate that something got touched. So you can see that now when I touch my flag, it says that we won. So for instance, if I was playing Legend of Zelda and I was walking into the first boss fight and I was passing through a doorway and that triggered this cutscene, I was like, oh no, Goma's here, she's gonna kick your ass. That's probably a trigger. I don't run into the wall, I don't get stuck, but I pass through and I still know that I passed through that doorway. That's what a trigger is. So we have a trigger on that flag so that we know that we touched it, but Mario doesn't actually run into the flag. All right. Good night, Kenny. Hey, so for anyone who is taking off, one of the things that I want to offer here, two things that I want to offer here. We are, this is the Indie Game Academy. Like I said, we do a whole lot of stuff here, including things like this. We have some paper prototyping events coming up, which some of you may have signed up for. The paper prototyping is one of my favorite exercises. We also interview a lot of different people. We have a podcast that we do live on our Discord, so you can come and talk to some members of the game industry, you know, get some war stories from them, figure out how they broke in. So you are all invited, since I know that you are cool people, into our Discord. Go ahead and click that link. And then if you want to chat with me, I do free career consultations / just like hanging out and talking. It's a way for me to expand my network and help sort of help pay it forward. I've had so much help myself breaking into the industry. So if you want to chat for just like 30 minutes about your career, you can go ahead and click that link and schedule a time with me. If anyone is leaving, feel free to do so. All right. So let's get let's get two last things working, and then we will officially call it quits. If you need to leave, I will not be offended if late. The two last things we're going to get working, which will both be pretty quick, is the piranha plant and the coin. On the coin will be super quick. Go ahead and click and drag your coin into your world. Make it a more appropriate size. Give yourself a circle collider or a capsule collider, whatever makes sense to you, on this coin. Add the coin component to it, the completed coin. And I believe it is also a trigger, which I can see because it says on trigger enter. It is indeed. So I also need to click is trigger right here on the circle collider. Heck yeah, Fernando. Please schedule a call. I'd love to chat, man. Thanks for coming. Sleep tight. All right. So we have a little coin in our world. Now, this coin is very simple. It doesn't do anything too advanced. It just messages. Thank you, Minha. It just messages. It just prints to the screen. So if I touch this coin, it will delete itself and it will tell me that I collected a coin. And that's all we need to do for that. And the very last thing, because it's kind of an interesting relationship, is our piranha plant is an enemy in our world. And this will be a script that you can use very readily. I'm going to make that, once again, a more appropriate size. Yeah, it seems about right. Put that right there. I'm going to add a collider to it, which this one, maybe a capsule collider, is actually good again. So Capsule Collider 2D. I'm going to add a component, destructor. Destructor. It is a thing that can destroy destructibles. A destructor, which has one variable called damage. That's obviously something that you can mess with yourself. And then on your player, I want you to add component destructible. And you can set how many hit points your character has. In this case, I'm going to give it 1 because that's more accurate to Mario. And now if I hit play, Mario will start the game. he can get the coin, but if he touches the piranha plant, he gets destroyed and the game ends. Wow. All right. So that is definitely, we're over time. That is everything I'm going to show you for today. Does anybody have any last questions? Or are there any
Yes.
bugs? What's going on?
I have a question. How do you see the game and the scene on the same screen?
You must have
Yeah,
missed
how
the
do
very
you-
beginning. Yes. Yeah,
Yeah.
this is, I agree. The way they do it is dumb. So basically any of these tabs, like the hierarchy, the scene, the game, can be dragged around. So all
Mhm.
you actually have to do is click and drag the game and put it somewhere that makes more sense to you.
Oh.
I tend to like it right there, right in the middle.
Okay, that was very simple. Thank you.
Yeah, no problem. Any other last questions? All right, so you guys will be receiving an email in the next day or two, depending on how well I do my own work, which will have a link to the recording of this class. So if you missed anything, I will also include the link to the Discord in there. We would love to have you at the Indie Game Academy. We're a bunch of dorks. Basically, we show people how to make games, like I said. Our main program, which is coming up in about a month, is a 3-month-long program where you learn from 7 industry professionals from some of your favorite companies. I will be there. I will be teaching. We also have someone coming in from Minecraft. We have someone coming in from Wizards of the Coast. And you run through an entire production cycle. So you're mostly learning game design and production. We don't teach you to code in this game. You work with a team, and that team works together to actually publish an original game to a store of your choice. So we love helping new people break into the space. That's our whole mission. I would, more art focused. Yes, actually, that's a great question, Colleen. Because it is multidisciplinary, we actually love having people who are not engineers, because a team of 5 engineers doesn't make a very interesting game. So we want people who aren't just doing code or just doing project management or just doing art. We want people who are doing a little bit of all of it so that we can put them in teams so that they can make cool games. So if that sounds interesting to you, you can definitely schedule a call and we can talk about it. If you just want to talk about kind of anything, though, I try to make myself available. So this Calendly link is really the way that I try to do that for everybody. Helps me out because it helps me grow my network, helps me meet cool people like you. And then hopefully I can offer you some advice on how to break into the industry or next steps for Mario, maybe whatever you want to talk about. As long as it's about games, I'm here to talk about it with you. And then, yeah, Indie Game Academy is also just goofy and weird and awesome. And we are, we think we're Jedis or wizards or something. So if that sounds like your crowd, come hang out with us. It's been great teaching all y'all. All right. Any last questions or anything like that? Of course. Thank you, Ellen. All right. Take care, everybody. You'll be hearing from me again in the next couple of days.
Thank you.
Hope everyone has a wonderful night. And I can't wait to see your next stream, Justin. Just kidding. All right. Bye now, everybody. One
Take care. Good night.
second here. Take care, y'all.